Okay, good afternoon everybody. How are we doing on this fine Tuesday afternoon? Ooh, you can't see me, let me just change this. Yes! How are we all doing? Thank you so much for joining. Hope you're all well. Hope you're having a fantastic summer. Thank you for those who've already joined. For those of you who are regulars, welcome back. It's always a pleasure. Thank you so much for joining. For those of you who are new, I'm Yusuf. I'm your host for these types of lessons. And we just do a bit of maths, have a bit of fun, have a chit chat, and essentially just learn something new every single week. I apologise for those who are expecting a stream last week. I am so sorry. I was actually in the middle of graduating, so I do apologise, but I couldn't get out of that for the stream, so I had to attend that. So yeah, I graduated last week, and very happy to do so. And yeah, I'm just relaxing. Feels a bit weird not to, have any responsibilities and just kind of have a lie-in every single day. But yeah, I'm enjoying it. I'm sort of on like a summer holiday myself. So, but yeah, hope everything is fine with you guys. If you're still at school, you're probably, I'm guessing you already had, your holidays have already started. So hope you're relaxing as well, re-galvanizing yourself and ready, to tackle the new academic year. So, yeah, as you can see by the title of today's stream, we are going to be focusing on direct and inverse proportion. There's two types, direct and inverse as they are, and we're going to try and get to the depths of how they work, what they what they consist of, and how they work, and sort of go around answering some exam questions on those as well. Okay, as always, feel free to message in the chat. Always let me know if once you enter how you're doing, how you're feeling, and also if you have any questions about what we're going through, because as you know, it's important to ask questions. Because if you feel like you need to ask something, more often than not, some other person will do as well. Okay. So, and one other thing as well, I am using a new whiteboard today from the My Tutors website. So I do apologise if I do make some mistakes in my annotations and so on and so forth. But without further ado, we might as well get going. I'll change over to the whiteboard. Yes, here we are. Direct inverse proportion. Here is the whiteboard, and as a starter activity to get you guys sort of thinking about what we're going to be doing, have a look at this. So I hope you can see it. I hope that's clear enough. If it's not, let me know. But yeah, this is what we're doing. So let's build an understanding of what we're actually talking about in terms of context. So when a long distance runner runs at 8 meters per second for some fixed period of time, he covers 240 meters. Okay, so we're just talking about speed and we're talking about distance, and we're going to change one of those variables. We're going to change the speed. Okay, and if we change the speed, obviously in turn the distance covered will change as well, because the time will be kept constant. So in the same time, if we double the amount of speed, what happens to the distance covered? Okay, because we're going from 8 to 16. If the speed is 4, what happens? And if the speed is 24, what happens? Just something for you guys to think about. Hopefully it won't take you too long, but there are some clues given. Okay, if his speed is doubled, then the distance covered would similarly double as well, and so on and so forth. Okay, so the proportions remain the same. Okay, thank you, Abdullah. You are correct. You're absolutely correct by saying we are multiplying by 30. But what would the individual values be? How much would they cover in the same amount of time if they ran at 16 meters per second, 4 meters per second, and 24 meters per second? Okay, I'm already seeing some answers in the chat. Absolutely brilliant. Thank you so much for doing so. So hopefully you guys had enough time to think about that. The actual answers, have I got them? No, yeah, I do. Yeah, so essentially the amount they cover in terms of the distance proportionately changes to the speed. So if the speed doubles, so does the distance covered. If the speed halves, so does the distance covered, and so on and so forth. Right? So in terms of the value that we had, here, 240, from here to here, what did we do? We times by 2, and so we do the same here. Okay, from here to here, we sort of divided by 2, and so on and so forth. And that is how it works. And the fact that everything is exactly proportional We call this direct proportion. This is called direct proportion. And someone also mentioned, can't remember who it was, I think it was Abdullah. Thank you, Abdullah, for mentioning. Yeah. In terms of the relationship between the speed and the distance covered, what's happening every single time? We're multiplying by 30. And the fact that we're multiplying, let me just put it there. The fact that we're multiplying by 30 every single time, that is important because we'll recap that time and time again in this topic. And that is actually called the constant of proportionality. So the constant of proportionality links our two variables together. In that if we have one of the variables, we can use the constant of proportionality to do either a multiplication or division to find the value of the corresponding other variable, if that makes sense. So this exercise was just, an example for you to understand what we're talking about when we mention proportion and so on. Okay. So what I'm going to do now is I'm actually going to show you a real life example of an exercise question or a exam question, so to speak. Okay. And I've just realized that some of my variables have gone missing. So what I'm going to do, guys, is bear with me. This is supposed to say x, not great, is it? X is proportional to, actually we'll do y is proportional to x. Y is directly proportional to x. Okay. And what we want to do is, then we don't have the values. Okay. Guys, I am so sorry. So sorry. We've had a bit of a nightmare start to this lesson. This is what happens when you use a new whiteboard and you do not properly check. I think all my math symbols have seemed to disappear. So what I'm gonna do is, bear with me, guys. Take a 30-second break. Have a swig of water, or whatever you can in 30 seconds, while I just load up the same questions on my iPad. I'm actually going to take a screenshot and try and load it onto the PowerPoint on this whiteboard. Okay, so bear with me, guys. Somewhat of a nightmare start. Hey, I'm so sorry. But yeah, so if you guys want to jot it down, what I can do is I can actually read out to you the question. The question is, y is directly proportional to x when x equals 3, y equals 7.5. So let me see if I can get it onto here. That's better. Okay. Can you guys see this? So I just took a screenshot of the actual PowerPoint. So we'll get back to it now. So y is directly proportional to x when x is equal to 3, y is equal to 7.5. Find a formula for y in terms of x, hence find the value of y when x is equal to 4.4. So, guys, in proportion questions, there are always two steps that you need to do. Okay, are the two steps you need to take. The first step is find the value of k. Now, what is k? What are we talking about when we say k? K is the constant of proportionality. Okay. And whenever you see this term here, directly proportional, okay, I want you to think kx, okay, or y equals kx. Mathematically, I've just translated this first statement or this first sentence, y is directly proportional to x, to look like this. Y is equal to kx. That is the first thing you want to write, okay? Because that's how you go about answering these questions. Once you write y is equal to kx, then you can sub in these values. Okay, an important point here. Your value of x and y, guys, they are always changing. They don't have a fixed value. Yes, when x is something, y is equal to something, and so on and so forth. But in terms of what they can be, their values can be absolutely anything. They're always changing. Okay, so x and y will always be changing. The only thing that remains the same is your k value. Your k value, we say, is the constant. Okay, so a constant is something that always remains the same. So your k value will always remain the same. So we say y is equal to kx, and therefore we can say that 7.5 is equal to k times x, which is 3. Okay, or 3k. Okay, that's what I'm going to write it. I'm actually going to write 3k. 7.5 is equal to 3k, and then how do we go about finding k? Well, we just divide 7.5 by 3. Okay, and you can leave it as a fraction or as a decimal, whatever you want. I get 15. No, I don't. One second, let me just double check. 5/2 or 2.5. Yeah, we can leave that as a decimal. So that's the first step you do. You find the value of k. And then all you do is, your second step is sub this value of k back into the original question. The original statement or equation. So now we say y is equal to 2.5 lots of x. Notice I haven't written a value for y and I haven't written a value for x. And this is important, this is crucial, because as I mentioned, y and x can be anything. Okay? When x is something specific, y is something specific in those contexts, but generally speaking, they can be anything. And then, so that's the first part of the question. It says find a formula for y in terms of x. We've done that because we have y is equal to 2.5 times by x. And then it says hence find the value of y when x is equal to 4.4. Okay, so we're going to find y when x is equal to 4.4. So in order to do that, we're going to sub x into this original equation. So we have y is equal to 2.5 lots of x, or 2.5 times by x. In this case, x is 4.4. So we have this multiplication. If you do 2.5 times by 4.4, you get the value 11. Okay. And I hope you guys managed to get that. This is how we go about answering questions on direct proportion. We always find k first. That is always the first step. Find k. Once you find k, substitute that in to find the second, or to answer the second part of the question. Okay. Any questions, guys? If you have any questions, put them in the chat. If you do not, no worries, Finn. Take care, man. It's been nice having you. If for those of you who are still here, if you managed to get that, let me know. Let me know if you can answer question 2. What I'm going to do is I'm going to give you guys maybe a minute or two, just to see if you can answer the second question, and then I'm going to go through it with you. Okay. And in the meantime, I'm actually going to just sort out this issue with the slide. Okay, yeah, take 30 seconds, guys. See if you can have a go. It's actually an exam question. I mean, very similar to the one that we did. But yeah. Okay, give you a quick head start, and then I'm just going to go through it now. Okay, so it says y is directly proportional to the square of x. When x is equal to 3, y is equal to 36. This time, what's different? Thank you so much for your answer, Abdullah. Let's go through it. Let's double check. This time we have y is directly proportional to the square of x. So this, if we translate it mathematically, we're talking about y being equal to k times x squared, because it says square of x. Y equals kx squared. So when x is equal to 3, y is equal to 36. So then we say that 36 is equal to k times 3 squared. Now k times 3 squared is what? It's 9k. And therefore, if 36 is equal to 9 times k, then we say that k is equal to 4. Using our principles of rearranging formulae. And then it says, this was our first step, our second step, find the value of y when x is 5. So because we have found k to be 4, our original equation becomes y equals 4 lots of x squared. So to find the value of y when x is 5, we take x, which is 5, we square it and we times it by 4. This gives us the equation to be y equals 4 times 25, and so y is equal to 100. Thank you if someone put that in the chat. Well done. If you didn't, double check where you went wrong, so you can figure it out, and then hopefully it all makes sense. Okay, let's move on to the next part. And again, having some trouble. Bear with me. Let me just put this there. Yeah, this is going to be a recurring theme. I'm so sorry. Seems to, yeah, it's not working. So we'll just stick with this for now. Now I want you guys to have a go at this. So R is directly proportional to Q. Different variables, guys, but same concepts. Even though it's R and Q this time, you can imagine them, to be the same as Y and X. Nothing changes really. It's just that they're different letters. Okay. Have a go at A, as I reckon that's relatively straightforward. When it says find the formula for R in terms of Q, all you need to do, guys, is you need to find the constant of proportionality. Remember what that was? The K value. You want to find the constant of proportionality and then write it in an equation with R and Q. Hope that makes sense. Then you want to use that equation to find the value of R when Q is equal to 17. I'm going to give you guys a quick head start, and then I'll catch up to you in a short while. Okay. And we'll go through the answers. Okay. And then I have some more exercises on the next screen. Yeah, a bit of a nightmare today, isn't it? I thought, yeah, let's go ahead. I mean, the truth be told, I had on my tutor. I don't know if you guys have lessons on my tutor, but essentially we have different whiteboards that we can write on. But the one that I was originally using, they got rid of it just spontaneously. Well, to be fair, it wasn't spontaneous. They had told us a while ago that they were going to get rid of him. But I just preferred that one because it was more compatible with. Clearly, it was more compatible with PowerPoint and stuff like that. So, hey ho, I'm gonna have to figure out a way to make it compatible in some way. Okay. Yeah. So I thought I'd bore you with that. Anyway, right. Right. What we're gonna do is I'm gonna slowly start catching up, guys. So if you are nearly done, or if you're still doing it, you might want to just ignore what I say and then sort of mark it in the end. Okay. So R is directly proportional to Q. Directly proportional, so we have the equation. R is equal to K times by Q. When Q is 12, R is 9. So that means R is equal to 9. So 9 is equal to K times 12. And so our value for K this time is going to actually be less than 1 because we're doing 9 divided by 12. Okay, 9 divided by 12 is simply 0.75 or 3/4. You can write it as a fraction or you can write it as a decimal. I'm going to write it as a decimal, so 0.75 is equal to K. Therefore, an equation relating R and Q is R equals 0.75 times by Q. And that answers question number 1. Because question number 1 says, find the formula for R in terms of Q, and that is exactly what we've done. We have R equals to 0.75 times by Q. The next question says, find the value of R when Q is equal to 17. So when Q is equal to 17, okay, so we have R is equal to 0.75 times by 17. Well done, Abdullah, for getting the right answer for SK, by the way, that's correct. If we multiply these together, what do we get? I get 12.75 to be my final answer. And I hope that makes sense. Okay, the nice thing about proportion is that you're essentially just redoing the same steps again and again and again. So once you are secure with the knowledge and you know how to answer the questions, you should have no problems, hopefully. Okay. The only thing that they might catch you out on is something like in question B, where they assign they give a sort of intrinsic difference to the type of value that you can have. So that we have square root here essentially. So how does that affect the answer? Well, you'll see. Again, I'll give you a couple, maybe just 30 seconds, 45 seconds head start. I'll start catching up, but remember guys, all you need to do is you write an equation with b and a this time, but remember it's square root of a, so what are you going to do with that a variable? Do some manipulation, substitute your values in to find the value of k then, and then once you have k, you've pretty much answered the question. All you need to do is just reuse that same equation to find the value of b when a is equal to 25. Okay. So we have, I'm going to start it now. So we have, actually going to change color. Let's go with blue. Actually, I like purple. So we have b is directly proportional. Again, if we translate this mathematically, we write b is equal to k times the square root of a. That is important. So we're going to write it as k times a with the square root symbol of it. When a is equal to 9, b is equal to 15. So 15 is equal to k times the square root of 9. Okay. And what is the square root of 9? Well, you know the square root of 9 is, that's 3. So we have 15 is equal to k times 3. If 15 is equal to k times 3, then what does k have to be? K has to be 5. Thank you very much, Abdullah. Your workings out seem to be very, very much correct. Well done. So then we have to find the value of b when a is equal to 25. So let's do that. So if we have b is equal to 3 times the square root of a, okay, then what do? We plug that in. b is equal to 3 times the square root of 25. Square root of 25 is 5. Plug that in, so our value for b is 15. Have I done that right? Have I done that right? Have I done that right? I feel like I've made a mistake, guys. Tell me where I've made a mistake. Yes, here, yes. Hopefully you guys already clocked onto this. But we made a mistake here. It should have been, this is, thank you Abdullah, your working out was better than mine. This should be a 5 instead of a 3. We have 5 times 5, so we actually end up with 25 as our final answer. Yeah. Thank you so much for those of you who tried this. If you got 25, really, really well done. Yeah. Really, really well done. If you didn't, again, just go over, check the method that we've done. Again, it's not that many steps, right? It's only a matter of doing a couple of things, then just doing some division and multiplication. Okay, yeah. Thank you so much, Abdullah, for letting me know of that. Okay. Right, so let's see if this works. Yes, here we are. We have some different exercises this time. What I'm going to do, guys, is I'm just going to give you 2 minutes. Excuse me. Just going to give you 2 minutes. Obviously, I don't expect you to go through all the questions or finish them all of them in that amount of time. But just do as much as you can, and then we'll go through the answers shortly. Okay. So the first question is: given y is directly proportional to x, find a formula for y in terms of x. Okay. Have some values of y and have some values of x. Okay, so you're going to have different values of k each time. So you're going to have, essentially, you're going to have 2 equations. One equation for when y is equal to 12, x equal to 3, and another equation when y is equal to 8, x equal to 16, so on and so forth. Okay, so you just, for this first question, you are just finding the constant of proportionality. And in the meantime, I'm going to continue to sort this whiteboard out. Okay. Okay, and then we shall move on to the next bit shortly. Okay, of course, if you ever have any questions, let me know. Okay, yeah, as I said, guys, I won't give you too much time for this. I don't need you to do all of them, just maybe practice 1 or 2 just because of time. I do want to do some inverse proportion stuff as well. Okay, and I'm actually going to Yeah, I don't think the answers are going to load. Let me see. Yeah, typical. The answers are not going to load. So what we're going to do is, where's it gone? Come on, man. Right, absolute nightmare today, isn't it? For those of you who didn't get the answer, circle theorem, Abdullah, actually that's a good question. I'm actually going to do that next week. Circle theorems is definitely on the agenda, so yeah, watch out for that. Okay, I do apologize, guys, doesn't seem to be working. We're just going to move on to inverse proportion. So what I'm going to do, Abdullah, I'm going to trust you and that your answers are correct. So for the first one, guys, you should have got k is equal to 4, as that is what Abdullah got, so I'm going to trust that he got the right answer. Okay. If you have any questions about any other ones, do let me know. I'll go through them later on. Okay, so now, we're moving on to inverse proportion, so I'm going to give you a bit of context surrounding that. So now presume we're running a 5,000 meter race, so 5 kilometers, and here are the times in which we complete that race when we run at different speeds. So when we run at 5 meters per second, our time is this. When it's 20, our time is this. 1, this, so on and so forth. Okay, and this kind of makes sense, right? Because if you're running at 1 meter per second and you're running 5,000 meters, you would expect that you would run it in 5,000 seconds because it's 1 meter per second. But what do you notice about this, guys? What do you notice? Previously, in direct proportion, if we increased one variable, the other one would increase as well. But what do you notice here? In this situation, when we increase something, the other variable actually decreases. And that is precisely why it is called inverse proportion. Okay, so inverse proportion is when you have something, okay, when you're talking about two variables, but when you increase one of those variables, the other one goes proportionately negative. So here is the general equation. So when we talk about inverse proportionality, guys, we say, so because it's in the realm of speed and time, the equation that I want you to write to find k is S is proportional to k over t. So ignore this. This is the more general one I want you to think of. Okay, or this sign just means directly proportional to. So you can have it as an equal to sign. It's the same thing. Okay. Yes, inverse proportion is k over x or k over t, whatever the question is saying. The only thing you need to remember is that k, your constant of proportionality, is your numerator, and then the variable that's in the question, whether it's time, whether it's x, whether it's, I don't know, distance, that is your denominator. And that is how you go about answering and finding the value of k. So let's have a go at some worked examples, okay, in which we have some inverse proportional questions. Okay. I believe one of them is an exam question, so we have some time with that as well. Let me zoom out a little bit. So guys, have a look at this. We have the following. We have y is inversely proportional to x, and when x is equal to 6, y is equal to 8. Find y when x is equal to 9. So let's go about doing this again. Y is inversely proportional to x. So first things first, I'm going to translate this original statement. This means that y is equal to k divided by x. Okay, that is what this is what is dictated by the fact that it says inverse proportion. Okay, and this is how it differs to direct proportion. When x is equal to 6, y is equal to 8. So then we have 8 is equal to k over 6. Rearrange this to find k. Obviously, k here would be 48. So our value, okay, or our equation becomes y is equal to 48 over x. Which means if you have your value of x, all you need to do is you need to divide 48 by that value of x, and then you have the corresponding value of y. So we'll do that now. Find y when x is equal to 9. So let's do that here. So we have y is equal to 48 divided by 9. Did I do it wrong? 42? Is it 42, guys? No, 6 times 8. Yeah, thank you. So y is equal to 48 divided by 9. Okay, it's not a whole number. Is it? No, it's not a whole number, so it'll give you a decimal. Okay, something like 5 point something, right? So 48 divided by, I'm just going to plug this in my calculator. We get 5.3 recurring, so I'm just going to leave it as a fraction. We get 16/3 as our value for y. Okay, nice and straightforward. Similarly, we have b is inversely proportional. So again, I'm going to change color. Let's do blue again. Thank you, Abdullah, for letting me know. So b is inversely proportional to the square root of a. So b is inversely proportional. So that means we have k. We have a fraction with k as our numerator to the square root of a. A with a square root symbol over it. So this is what I mean when I say you always have to translate the statement given in the question mathematically so that you have some sort of representation in an equation. So this is the equation that we have. When a is equal to 4, b is equal to 10. So when a is equal to 4, b is equal to 10. So we have 10 is equal to k over the square root of 4, which is 2. So we have 10 is equal to k over 2. Therefore, what is our value for k? Well, it's just 20. So if we rewrite the equation and put what the value of a was, we have b is equal to 20 over the square root of a. So find b when a is equal to 25. So b is equal to 20 over the square root of 25, which is the square root, which is 5. So we have 20 over 5. 20 divided by 5 is 4. Thank you so much, Abdullah. You are 100% correct. So as you can see, guys, the steps are pretty much the same when it comes to direct and inverse proportion. However, the only thing that's different is the actual original equation that you start with. When you have direct proportion, you are multiplying k and your variable. But when you have inverse proportion, you are dividing k by your variable. And that is the key difference that you need to remember. I don't believe you're given these equations in your, actually I'm pretty certain you're not given these equations in your exam paper. So it is absolutely imperative that you know how to reuse them, but also you just remember them as well. Because, the reason why most people lose marks on this is just because they forget the equation. They forget what the equation is for inverse proportion and what the equation is for direct proportion. Obviously, it goes without saying as well, if you have some sort of extra detail, something like the square root of a or a squared or a cubed, always incorporate that as well. So I hope that's helpful. As always, I'm just going to give you a couple of exercises to do, guys, and then we will sort of round up our learning. So bear with me as I just load it for you. I believe this is an exam question, so I might need to just review it before we do. Let's zoom out. Okay, so this is from the November 2010 paper. P is inversely proportional to V. Okay, again, we have P and V this time. Doesn't really matter, still the same thing. The key thing is inversely proportional. P is inversely proportional to V, guys. When V is equal to 8, P is equal to 5. Find a formula for P in terms of V. What that means is you take your you take your equation for inverse proportion. Okay, so is it the one where we have K times, or is it the one where we have K divided by? You take that equation, you use that to find K, and then you just you rewrite the equation with your constant value within it. Okay? So I'll give you a couple of minutes, or maybe just a minute, and then we'll go through the answer. Okay, guys. And then I believe we'll do one or two questions on this, and then we'll just wrap up for today. I do have a sort of last minute exercise for us to do as well, if you guys want to have a go at it. It's not exam questions per se, but it's just like little exercise questions that you could have a go at. Okay, let's go through this. What do we have? Where's my pen gone? Let's do this. P is inversely proportional. I already see an answer. Thank you, Abdullah. Let's go through it together and just double check if you got the right answer. So P is inversely proportional to V. Well, let's translate this. This means that P is equal to K over V. And I'm going to double check. Is there any extra detail? No, doesn't say square root, doesn't say square, so V is just on its own. Okay, that's a key detail that you need to remember. P is equal to K over V. That's what we start off with. When V is equal to 8, P is equal to 5. So 5 is equal to K over 8. Therefore, rearranging this equation gives us a value for K, which is 40. And we're done pretty much. All you need to do, guys, is you should plug this into here. You started off with this, you're going to end with this as well. So you have P is equal to K over V, but we now know K is 40, so we write 40 over V as our final answer. To be honest, when you think about it, guys, how many steps was that? It was 1, 2, 3 steps. Okay, but it took us less than 30 seconds, 40 seconds, and it's 3 marks. 3 marks is a nice amount of marks. Well, there's an extra mark here available as well, but that is a nice amount of marks just for doing a bit of rearranging an equation. Okay. Then it says calculate the value of V. Sorry, the calculate value of P when V is equal to 2. So we know P is equal to 40 over V. So then if we want to calculate the value of P when V is equal to 2, let's sub in V is equal to 2. P is equal to 40 over V, which is 2. 40 divided by 2 is 20. And that is that. 20 is your answer, and that is how you obtain all, thank you Abdullah, correct as well. That is how you obtain all the 4 marks on this type of paper. Okay, or on this type of question. Any questions, guys? I mean, Abdullah, well done. You seem to have really grasped the concept of this really well, so well done. Okay, that is all the questions that we have. As I said, there is a little exercise that I want to have a look at with you guys, and I'm just going to do that. And that basically we'll end it here. It's just a quick fire set of questions on proportion. And here it is. Let's zoom out. Okay. So all you need to do, guys, we're not doing any numerical calculations. We are just figuring out what the first thing we would write is if we read the following statements. So if the statement in the question is y is directly proportional to x, what is the equation you would write? Okay, so no numbers, just variables in k. Similarly, y is inversely proportional to x, y is directly proportional to the square of x, y is inversely proportional to the square of x, and so on and so forth. Okay, and then we have cube of x, and then we have cube root of x. Okay, this is a tricky one. Okay, but if you can sort of understand this, then it shows you have a really solid understanding. Okay, Abdullah asks, what did you get in your GCSEs? I was very fortunate to obtain a grade 9. I was actually the first cohort. I don't know if you will care about this at all. I was actually the first cohort or the first year group to take the 1 to 9 exams. We only did it for English and maths, so it was a bit weird. So we had number grades for English, maths, and yeah, that was it. And all other subjects, things like science, history, all that kind of stuff, it was letter grades. So it was a bit confusing because we were the first group trying to explain to our parents that, ooh, 9 is a good grade. But yeah, it was a weird time. I think now all of you guys just have numbers, which is nice, because I mean, I don't really know the reason why they changed the numbers, but I think numbers are nice. I don't mind them. I think they're great. But yeah, I was very lucky, or very honoured to achieve a grade 9 in maths. It's not easy. It takes a lot of hard work. Yeah, I would say that. Okay, and then I managed, and then I did. That's why I did maths at A level. And then the geek that I am, I did maths at university as well. So yeah, that is what we do. Okay, Abdullah, you're an absolute gem because you seem to have done all of them. So what I'm going to do, guys, I'm going to quickly write out the answers you should have got. I'm actually going to write them out in white on top of this. Let me see if I can zoom in. Yeah, so we have y is directly proportional to x. What is this? This is simply y is equal to kx. Y is inversely proportional to x. So y, remember guys, whenever you see inversely proportional, you should create a fraction. Y is directly proportional to the square of x. We have y is equal to kx squared, I believe. And then we have y is inversely proportional to the square root of x. Like so. Hope you got that. Y is inversely proportional to the cube of x. So let's do that. It's inverse this time, so we are going to have a fraction. And it says cube of x, so it's x cubed. And y is directly proportional to the cube root of x. That is y is equal to k cube root of x. Put that there. Okay. What did you get in your science GCSEs? So yeah, like I was saying, I didn't get numbers. I got A's across. So I did triple science, and it was literally A, which is a bit boring. So I think in terms of equivalent, it would be a 7 or maybe a 6. I think it would be a 7 in the current realm of grades. Okay, but yeah. Not a scientist by any stretch of the imagination. Did do at A level. I had to do chemistry and biology, just because what I wanted to do at university at the time. But yeah, not a great scientist. Mathematician. Numbers are my game. Although chemistry is a lot to do with numbers, to be fair. But yeah, the others, and physics as well. Biology, oof, not a fan. Right. Here you go, guys. Here are your answers for the quickfire questions. Mark them off. Let me know how you did. Also, let me know. Firstly, I do apologize sincerely for the issues that we had. Let me just move over. Yeah, I do apologize sincerely, guys, for the issues that we had with the whiteboard. We'll try and fix them for tomorrow. For next week's lesson or stream. Next week, I'm thinking, as was mentioned by one of the students in the chat, I'm thinking to do circle theorem. So if that is something you'd be interested in, definitely tune in. There's about 9 circle theorems in total that you need to know. Some of them are easier, much simpler. Others are a bit more complicated. So we'll go through the more simpler ones to start with, then try our best to get through all of them. Okay, so if you are interested and you feel like you do want to, be part of that and you want to improve your knowledge of circle theorem, definitely do attend. I know you guys are off school anyway, so hopefully you can find an hour or so in the week just to do some recap, because 6 weeks is a lot of time, guys, and you'll be surprised how much knowledge can just sort of evaporate from your mind within that stretch of time if you do not do things like weekly recaps and stuff like that. Okay, so I would definitely recommend it, guys. I know it's something that you don't want to hear, but genuinely from experience, it is something that will help you quite a bit. Okay, other than that, if you have any other questions in regard to anything, your maths, your general advice, anything like that, ask me now, because we always allocate the last few minutes to this to a Q&A sort of thing. So if you do have any questions, let me know. I do hang around in the chat afterwards anyway, so let me know. Okay, so I'm just going to stick around, see if there are any questions. If there are not, then we'll wrap up for today. Okay. So if you have a question about anything, a question one of my students asked me the other day was, we had a last session before they went for their summer break, and they were saying, if I can minimize the amount of work but maximize the efficiency, what should I do? And I thought that was a really good question, because I think that'll probably apply to most students. You know, how can you reduce the amount of time that you spend working but also maximize the amount you get out? I would say just increase randomness. So if you guys are not aware, there's a really neat website called Corbett Maths. And I would suggest, if you want to minimize the amount of work you do, I would suggest go on to Corbett Maths. I mean, I can try and show you. Let me see if it works. So shout out to Corbett Maths. Let's see, can you see? Yeah, so this is Corbett Maths, guys. If you go on to Corbett Maths, I would suggest go do these 5-a-day sheets, okay, because they won't take you long, and they have different levels. So they have foundation plus, higher plus, so on and so forth. So you can tailor it to what you'd like it to be, okay? So, and you can pick any random ones, and they'll give you some questions. Okay? 5 random questions on random topics. This is something I would definitely suggest that you do in the summer holidays. Don't know what's going on back there, I do apologize. Something that you should do in the summer holidays to really maximize. Yeah, Maths Made Easier, Maths Genie as well. Thank you so much, Abdullah. So these are the sort of websites you can be utilizing in your free time or in the time of your summer holidays to really make sure you're not missing out on anything, okay, or sort of doing your end of the work, okay. Right, other than that, I think that is all, okay. As always, I will stick around in the chat if you have any other questions, but for now, thank you so much for joining. I have been Yusuf. This has been Math Squad with myself. It's been an absolute pleasure. You guys are legends. Thank you for your work. I shall see you all next time. Thank you guys. Take care. Bye bye.